To best highlight the capabilities of the Elastic SIEM and how it can be used for security investigations, we have a small environment where we simulate various security incidents. The environment is composed of two victim machines, a Windows 7 and a Windows 10 virtual machine. An attacker machine, for which we'll not be disclosing any details, as we'll discover them during the demos throughout the course. As for the security capabilities, we have the Elastic Stack, where all the machines will forward logs to. Another virtual machine which has Zeek IDS deployed. This also has Packetbit installed as well to collect network data. And finally, we have a sinkhole based on iNet SIEM. This will act like a network gateway. Some of the legitimate traffic that we'll be seeing will be between the Windows VMs and the Elastic Stack, where all the logs will be forwarded, and also to and from the gateway. We expect that malicious traffic will flow to and from the Kali Linux machine. Although these are based on the same network, most of the attacks can happen across the internet without any limitations. It's important to know more about the data that we're collecting from the Windows virtual machines. We are collecting the security, system, and application logs. On top of that, Sysmon is deployed on both machines, and the logs that are generated are also forwarded to the Elastic Stack. To track persistence, the task schedule logs from the Windows 7 VM will be forwarded, as well as the PowerShell script block logs from the Windows 10 machine. Now that we are familiar with the environment, it's time to investigate some suspicious events. To build more context on this, in order for attackers to maintain control of a compromised system, the remote access tool has to maintain persistence. And this means that if a computer is turned off or rebooted, the malware will be executed when the computer is turned back on. There are various mechanisms to establish persistence on a Windows operating system. A very common one used by attackers is through scheduled tasks. And there are specific events that will enable us to detect this activity. In this demo, we'll go through a simple threat hunting scenario for scheduled tasks. This will be based on the Windows event logs. And we will look for suspicious events based on the MITRE ATT&CK framework. More precisely, we'll be looking for events where scheduled tasks are used to establish malware persistence. To know what to search for, we'll be using the MITRE ATT&CK framework. Scheduled tasks are identified here as one of the techniques. And here we can find more documentation on the technique itself, as well as in which campaigns it has been used. The part that interests us the most is the detection section. And we can see here that event ID 106 corresponds to a new scheduled task being registered on a Windows 7 system. Even more, if we want to capture these events, it describes here the exact location of the logs. Luckily, this has already been configured in our environment. So let's jump to Kibana. We'll first select the WinLogbit index, where all the Windows event logs are stored. Next, we set a filter for the task schedule event category, and we'll add in the event code of 106. And we're in luck. We've just identified something suspicious. Let's drill down a bit more to get more details. Here we can see the name under which the schedule task has been created. Let's search for this to see if we get a bit more information. We have to switch the category to Sysmon, as this captures command line events as well. Drilling down a bit more into the findings, we can see the exact command which was executed, even the parent process, which does not look like a legitimate Windows binary. I hope you're getting really excited, as this is only a small part of our bigger investigation.